So before I take your questions, I'd like to go over a very small demo. So over the weekend, if you got any parts of the cast or inheritance nodes that you want to try out, this is how you should try. Okay, I'll just show you one example quickly. Before I go to Eclipse, let's say this is the thing I want to demonstrate to myself. Okay, let's say I have an inheritance hierarchy over here. Let's say we got class A, and then let's say at one branch we have B, we have C, and we have D, and here we have E. Okay, let's see how we can try to reproduce what we said about compilable cast versus runtime exception-free cast, or some cast that will result in runtime cast exception, right? Class cast exception. Okay, let's see. So now let me just sketch the idea quickly, and then we'll do it together on Eclipse, so you will know how to do it by yourself. Let's say we try the following. Let's say we got B objects is assigned to new C. Okay, let's say that's what we have. And we know very well static type is B, dynamic type is C. Is this allowed? Yeah. Okay, good. So now let's try the following, okay? If I try to say, I want to cast obj over here into, let's say, A. Is it a valid cast? It's an upward cast, right? So it's valid. Okay, make sure you're okay with that, right? I just want to illustrate to you, okay? And then, if there's a valid cast, however, if I try the following, if I simply say A, let's say object A is assigned to this, would that be okay? That's okay, right? Because now the cast version over here has a static type A. Is A a descendant class of A? It is, okay? So that'd be fine. We'll try that in Eclipse. I just want to show you a few examples. Similarly, what if I do the following? Let's say I do a similar cast. I say A here, okay? It's still upward casting. But now, OB, let's say O, B over here, and then I'm just playing with the variable here. Can I do that? Gets a little bit trickier, right? That's something you want to get comfortable with for Tuesday. Okay, so now, why would that be? Are you saying the cast is not valid, or the substitution is not valid? It wouldn't compile, but can you tell me why? But again, we got two parts, right? The first part is about the cast. This cast seems to be okay. What about this assignment here? It wouldn't work because A is not a descendant class of B. Okay, good. Okay, let's do one more, okay? So now, let's say, okay, we'll still keep this object here. I want to do something with it. If I say obj, I want to do two more things. Obj and then cast to D. Would this compile? Aha, it compiles first of all. Okay, well, Stefan is pretty quick, but you know, you don't have to be this quick. As long as you can answer within 10 seconds, you'll be fine for Tuesday, okay? So now this guy here, apparently you're trying to downcast from B into D, right? So it's a downward casting, first of all. And then D is a descendant class of D, so that's fine, all right? One more, just to be complete. Let's say we got OE over here. Would that compile? I heard no. Anybody? Would that compile? Why? Yeah, when you say they don't have any relation, that's true, but you want to be more explicit in the writing. You want to say it's neither a upward cast, well, you can see the static type is exactly over here, right? It's neither an upward casting nor a downward casting, it's E. That's what you want to say. Okay, good. Okay, so this will not even compile. Okay, let's try all these on Eclipse quickly. I want to show you exactly what you will see. Okay, because so far I haven't really tried Eclipse for you. I thought it might be nice to begin start by this. So first of all, how do you reproduce this hierarchy here? Basically, you gotta create 5 classes, B extends A, C extends B, D extends C, and E extends A, right? Let's do that quickly. And then I'll show you line by line, okay? I think you really want to see this. Okay, so what I would do is, if you got your Eclipse, I'll say new Java projects. I would say example, let's say review, Simplecast. Okay, that's the projects. Let me build the classes very quickly. Okay, first of all, I'll get class A. Okay, class A. Okay. And then I will have a subclass called B. B here, and then over here for superclass, you can just put A. Okay, you can see they put extends A for you already. Okay, and then C extends B. C extends B. Okay, and then D extends C. D extends C. Finally, E extends A. You can feel free to make this example as complicated as you wish, just to try several things. Okay, I'll just do some simple demos to you. Okay, so that's the hierarchy we got. Okay, you can double check. Let's try the first thing. Okay, I can look at my note. Oh, let me create just one more class for tester. So now new and then class. Let's say Simplecast I want to generate a main method. Okay. Okay, let's try this. Let's not worry about JUnits for this example. I think console application will be fine. Number one, if I do B obj is assigned to new C. Well, this one here, you can see compiles, right? The yellow underline over there simply says you declare this variable without using it. That's only a warning. It's not an error. Okay, so that's fine. C is a descendant of B, so that's fine. Okay, the next one, if I try OA is cast, and then OBJ. You can see the compiles because of upward casting, right? Okay. Valid upward casting. Okay, the next one, this one is also fun. So now you can see that basically what I'm doing is I'm doing the same cast. But on the left-hand side, what I'm doing over here is I say B, OB. Okay, now it does not compile, right? Of course, in the written test, you will not be able to use tool to check for you. I tell you what, even if you use a tool to check for you, let's have a look at the error message over there. It's not very useful. If you move your mouse over, it simply says, type mismatch, cannot convert from A to B. If you write this reason as why it doesn't compile, not very high marks. I wouldn't say 0, but very close. Okay, that's not what you want to say. Okay, what you want to say is as follows: valid upward casting on the right-hand side. Okay, as we agree. So this part here is fine. However, invalid assignments because, okay, let me just spell it out. The cast version has static type A. By the way, during the test, I would suggest spell out static type. Don't say ST. The TA may not know what ST is. And also DT. Okay. Feel free to copy and paste. That's fine. It's a written test, right? Okay. So now, when we say over here, cast version has static type A, which is not a descendant class of the static type of OB, which is B. Okay, that's kind of the explanation you want to get, right? Question?
Would the equivalent explanation be which does not fulfill the expectation? So A, because A does not fulfill the expectation.
Okay. I would say if you only say A does not fulfill the expectation for B, I would say that was not perfect. Okay, it's almost there. But I would say as long as it's said about descendant classes, I think that'll be better. Okay, but you definitely get partial marks. Yeah. You want to say it will fulfill the expectation just because it's a descending class. Okay? Okay, I'll give you the perfect answer. Descending class of B over here. Therefore, the right-hand side can fulfill expectations on OB's static type. Something like that. Okay? Yeah. All right, so this wouldn't compile. So for now, I'm just going to put it into comments. Okay? So now, okay, this is number 1, 2, 3. Okay, let's do number 4. Number 4, if I try the following. This one is fun. OD is, over here, I would say D, and then OBJ. Okay? Have a look at it again to remind yourself. We are basically saying we have OBJ over here from line number 6. You can see line number 20 compiles because 2 reasons. Okay, I'm going to write it down. It compiles for 2 reasons. Compiles because, number 1, the right-hand side is a valid upward or downward? Downward, right? Okay. And number 2, it is a valid assignment because the cast version on right-hand side has static type D, which is a descending class of the static type of left-hand side, which is D. Okay? Now, compiles, so we may execute a code. What are we going to get? ClassCastException, simply because, I'll write it down, but executing this line of code will result in a ClassCastException. Okay? Can anybody tell me the reason why you will get a ClassCastException? Stephen, go ahead.
Because you're casting the object B into a class which is not in the ancestor path of the dynamic type C.
Ah, very good. Okay, let me explain again. Okay, very good. Okay, the reason that, okay, this line is very important. Okay, this line over here, okay, that's the line we're talking about. It compiles, as I just explained. Okay, so now why would it be a ClassCastException? So now dynamic type is basically class C over here. That's the dynamic type. And the static type over here, let me also mark it, it's B. Okay? That's the static type. And now we are trying to cast that into D. That's what we are trying to cast into. That is not good, right? Because conceptually, C cannot fulfill the expectation for D, right? Because it's ancestor. What would be the ClassCastException free cast? That would be anything that's in between the static type and also the dynamic type. Or in the ancestor path of the dynamic type.
Sorry, wouldn't
Yeah, actually, you can
go to A?
You can also go to A if you wish.
Yeah.
Okay, so let me put it down. So now, ClassCastException free. Okay, let me write it properly. Okay, again, we covered this in the class. I just want to review quickly for you. ClassCastException free if the type to cast into is an ancestor of the dynamic type. Okay, I'm just being lazy here to say DT, but you shouldn't on the written test. Okay, we just see. Okay, that's the reason. Okay, you can refer to this the notes. Okay, I don't need to type in the Eclipse. So let's say we try to execute, and then, ClassCastException. Right, I'm glad I showed you today. Right, it's really happening. And now if you simply, it tells you which line is throwing the exception. If you simply click on line number 30, exactly this line that's throwing the exception. Okay, I would suggest at least you try to really build this example from scratch yourself so you can get some impression about it. Okay, I would suggest. Okay, one more thing. Okay, yes, go ahead.
In line 16, I think can should
Yes, thank you. Very good. Very good. Yes, just typo. Thank you. Okay, so now let's do a final one. What I would do now is to say, remember the static type was B, right? Static type was B. Static type was B. I'm now trying to cast into something that's neither ancestor nor descendants, right? Let's see what's going to happen here. Okay, so now I'll come back here, and then I would say E, object E is E. Okay, compile time error. Let's read it. Cannot cast from B to E. You can see how useless it is, right? Right? So in Eclipse, it simply tells you that. It doesn't bother to explain to you for education, but I explain the whole reasoning to you. That's what you learn, okay, from this course. Okay? Does not compile because it is neither a upward casting nor a downward cast. Neither. Okay, that's why it doesn't compile. I'll just comment it out. Okay, I'll make the code available to you, okay, after today. I would suggest try to do this kind of exercise yourself. You can still try the instance of. You can also try maybe defining some methods in different classes and see which version get called, right? That's the kind of example we explain in the class. Try to do that so that can make your intuition more straightforward during the written test. Okay, that's something I'd like to start with. Okay, now I can take your questions. Go ahead. Oh, you asked me that question yesterday. Good. Yes. How can you will be given, I believe, 40 minutes, right? Like the last time. Was it 40, right? Or yeah. Too short, too long? Too short. Oh, too short. Okay. I'll try to make it not too many questions for you. I can tell you. Okay, how about I'll give you a tip here. Inheritance, it's definitely there. For sure. Okay. It will be inheritance there, and then another either 1 or 2 question. I'll give you maximum 3. That's what I can say. Okay. Inheritance will be 1 question there, and that one will be similar to. Oh, I wouldn't mind writing that down. Okay. Let's be fair to everybody. Inheritance is for sure there. How do you prepare that? Number 1, try the Eclipse demo just to really convince yourself. Okay? And then number 2, the practice test I gave to you, right? Like also symbolic exercises. And I will expect you to extend this particular practice test a little bit more in the following way. For example, if I say, for example, let's say, I'll give you some idea. If you have a class over here, call that collector. I'll give you one example right away, actually. Let's say we're using this particular hierarchy, right? If I say add, let me choose, let's say, C. That's kind of the polymorphic feature parameter that we talk about, right? So now, if I have this particular one, now if I have a testicle, okay, a different class, I might say collector, and then C is new collector, okay? And then I can say C.add, okay? Now, if I say new, easy one, B, would that compile? Are you sure? Are you sure? Good. If you're sure, yeah, if you're sure, say you're sure, right? Okay, good. Because you're expecting C, but you're getting a B, right? Okay. Yeah, that's kind of the stuff you want to extend the example into, okay? So now it wouldn't compile. because B over here cannot fulfill, I'll just follow your sentence, right? Cannot fulfill, and over here is expecting C, right? Because B is actually an ancestor class which cannot fulfill the C. Okay, that's one example here. Okay, inheritance is definitely there. You want to do this kind of extension yourself. Okay, yeah. Okay, and then after this, I would say there will definitely be one question about inheritance, and another 2 questions. Okay, rather than I think you got 5 last time, right? So this time will be 3. Okay, will be 3. Okay, and it could be basically different kind of topics, right? Basically all the possible coverage, from the exam, from the not the exam, sorry, for the guide. It could be something about hash code. I'm not saying it will be. I'm just making some example, right? It could be hash code. Okay, don't blame me if there's no hash code question, right? There might be hash code. There might be something about equals. Might be something about call by value. Or something about collection. I'm not really trying to give you an exhaustive list. I'm just saying I expect you to study. Okay? Oh, no recursion. Okay, if you're still wondering, no recursion.
Is it never in the final though?
Oh, the final exam, for sure, there will be recursion. Somehow you guys are lucky, because in the programming test, you will not ask recursion question. I heard that the other 2 sections, they will ask.
But it didn't have inheritance.
True, that's true. But I think I'm not sure if you've tweeted that way. I thought you guys are lucky because you knew the whole story about inheritance, right? Well, if you think that way, I'll be very happy. Right? Okay, about this, yeah. Oh, how do you make more efficient? I would say start with the inheritance question first. Okay, you want to draw a diagram, and then you want to be able to, I might just give you the class, like A extends B, B extends C. You want to draw the diagram right away, okay? And then you want to, the question I will ask you would be very similar to how I explain things in the class. Why would it compile? And why would it not to compile? Would you get ClassCastException? Okay? I can even tell you that. I don't mind. I really like these particular slides. If you don't mind, let me show you that. Okay, let me go to the lectures page over here. And if you go to inheritance, over here. Oh, guys, by the way, last Friday, in case you didn't make it to the makeup class on the polymorphic kind of stuff, remember it's covered. That's why I recorded the lecture. Please make sure you catch up on that. Okay? I want you to look at this slide over here. Bear with me. I'll be there. Almost there. Almost there. Aha. Okay. Okay, I'll make it bigger. Okay, if you recall, actually that's done in the very beginning of the kind of on the the first half of last Friday's lecture, which is covered. I want you to really go over 2.2 over here, 2.3, 2.4, 2.5. I may put some question related to it, or I may not. How about that? So you'll study that if you can. I don't want to make it so definite, right? Okay, I hope the hint is clear to you. Okay. Of course, you don't memorize what's said over there. I might present it in a different form, right? Really trying to understand what's going on over there. Why would you get a ClassCastException? And why would things not compile without a cast? Okay, things like that. Right. No problem. Okay. Okay. Am I giving too many hints? Not too many, right? Okay, maybe too few, I guess. Okay. And then I would say for the other 2 questions not related to inheritance, you have to be comfortable with drawing some diagram. For objects, I might simply ask you about, let's say you try to do some aggregation like what we did in the class, right? I might just ask you something related to aliasing, maybe. Okay, yeah. Okay, 40 minutes. I would say inheritance questions should be no more than 20, and then it should be 10 minutes each for the rest. Okay.
Will there be kind of like composition mingled with inheritance kind of thing?
No, I can tell you no. I wouldn't be so tricky.
Okay.
The question was, would I try to mix inheritance with composition together? No. Okay. It kind of did it for the copy constructor for programming test, right? Yeah. Yeah, I really care if you understand inheritance. I personally care. So I hope you will get it. Okay. Yes?
In the notes, when you said dot add, right, it couldn't cast you show the note, the iPad note?
Are you talking about the iPad or the slides?
No, the note, the one you just wrote.
The iPad?
Yeah.
Okay. Oh, I see what you mean. Yes, yes. Over here, you're talking about this example here. Yes.
Instead of new B, it could be a new A.
Yeah, of course. If you there are different ways to fix it. I'll just suggesting some way. That's related to the slides I just showed to you. Let's say if you say new B here, it wouldn't compile. What you can do is we're expecting a C, right? C is exactly over here. So now, what you can do is to say here, cast that into C.
Yeah, casting, but if it was new D, could that work?
New D. New D. Would it work? Yeah, D is a descendant class of C, right? Okay, different ways to fix it. Okay, you can either change from B to D. That will be okay. But now, question for you. Okay, and make sure you got it. What if I don't have this second? Let's say I just cleared it up. Okay, what if I simply say I will put a cast over here to say I'll cast new B into C. Would it compile? First of all, would it compile? I'm casting from B into C. It will compile, right? Am I going to run into ClassCastException? Let me make this one very clear, okay? Let me just right beside over here, okay? Let me do it again, okay? So now this one is worth trying. You say class collector. Okay, let me remind myself. Over here we say add C, okay? C array, CS, okay? Void, add C. Actually, add would be okay. And then C over here, and then OBJ. And you can implement that yourself, okay? And my question is, you can try some test code right here and say, collector, I call that C, right? Okay. Is new collector. Okay. And then can I do something like this? C.add. Okay. I'm writing in slightly different colors so you can see. Okay, that's basically what I'm saying. Basically, I'm creating a new object of type B, dynamic type. I'm casting that into D and pass the cast version into C.add. Okay, guys, any comments? Feel free to speak up, right? ClassCastException. Okay, so that means you believe you will compile, right? Would it compile, first of all? Would it compile? It will compile because you're casting from B to D, which is downward casting. And then when you try to evaluate this cast at the runtime, can B fulfill what's expected on D? No. Okay, so it's a ClassCastException. Okay. Yeah, just another example, right? This kind of example you want to be familiar with. Okay, I'll write it down here. It's a valid downward casting from B to D, number one, okay? However, you get a ClassCastException because the dynamic type, again, please don't write DT in the test, right? Dynamic type, which is B, cannot, it's not a descendant class. It's not descendants of the cast type D. Okay, that's complete reasoning. Yes?
When you say new B, so what is the static type of that?
Ah, good question. When you say new,
You're saying
yes.
non-casting, but you don't know what is the static type.
Ah, that's a very good question. I would say this one is a little bit in the gray area. You're right. Because over here, yeah. When you talk about new B over here, it's anonymous objects. So you're just creating a class without, you're creating an object without assigning that to a variable. So over here, all you rely on, whether there's an upward casting or downward casting, is to see whether you're casting to either ancestor or descendants of this particular type over here. It's kind of in the gray area. Yeah. Mm-hmm. Yeah.
Technically, that's a dynamic type, right? B is dynamic type.
D is dynamic type. Yes, that's correct. But in this case, static type is not really relevant over here. It's not really specified. Yeah. But it's a good question. I would say somehow Java allows this kind of flexibility, right? But you're absolutely right. Every time you want to judge to see whether the class cast is actually valid, first look up the static type, if any. If there's a static type, and then you can see the upward, downward. In this particular case, yeah, just look at the dynamic type. Yeah, it's a bit. Yeah. All right. Guys, any questions? Go ahead. So, just before I take a question. So, I'm also currently teaching 3311, the software design course. So later on, when I believe all of you will take it eventually because you're in CS major, right? So a big topic in the course is called design patterns, in which we are trying to show you patterns of recurring solution for common problems for programming. And we use OO. And then whenever we talk about OO pattern, almost every pattern we discuss requires the understanding about polymorphism and dynamic binding. So that's why I'm hoping if you see me again, let's say in 1 year time, for example, in 3311, okay? In that case, hopefully at that time you haven't forgotten about these details. But we'll review that anyway. Okay. But I'm just saying this important topic. Yes, question?
Moving away from inheritance, if that's okay.
No problem.
I was wondering if we could just briefly go over any practice tests for the lab test.
Sure.
At the very end of the composition and aggregation test, there's the, like you said, set x to 100, but then it's line 115 to 60.
Oh, you're wondering about why it would. Okay, I see what you mean. No problem. No problem. I think that is a valid question. Yes. Okay, you know what? What I should do is just bear with me for 1 minute. What I should do is I should download it. Okay, I believe that's the programming test, right? The programming, yeah. Aggregation, composition, starter projects. Good. Yeah, let me save it. Give me 1 moment. Okay, I'll save that to, let's say, desktop over here, and I'll import it. And then I'm going to import the projects, import, and then existing projects, select archive. And then I'm going to go to desktop. Okay, good. Let me close all the files. And then I will go to exercise 1. Are you referring to aggregation or composition?
I think it's
In a test for both, okay?
yeah.
No problem. Oh, you know what? Maybe I should have downloaded the solution, right? Okay, bear with me 1 more minutes. Maybe I should download the solution. Oh, I did? Oh, already. Oh, yeah, you're right. Sorry. Yeah. Thank you. All right. And then I'll say file, and then import existing. And then exercise 1 solution. Okay. And then I'll say finish. Okay, let's look at aggregation first. Test aggregation over here. Let's see what's the expected behavior. Okay, let's see this. Okay. Okay, let's just tell you what the intention is for the test. Okay. If you look at that, line number 158. Okay. So what we are saying is somehow LC2 is a line collector. Get a line at position 0, and then get its starting points, and then get its x. That should be 2. Okay. What's happening over here is like this. Okay. Yeah. Okay. Give me one moment. I'm going to write it down on my iPad. LC2 dot get line at position 0 dot get start dot get x. Okay, good. First of all, this particular structure here tells you certain links that should be followed at the runtime. Okay, what's happening is like this. LC2 is pointing to some line collector, and then one of them is called lines over here, for example, right? Lines, and then it's apparently an array of certain size, and we're getting a position 0, right? So now 0, 0 over here is going to refer to a line objects. And if you recall, every line got start and end, right? So now you got start and you got end. And then start is actually going to give you just another points. And then finally for the point we got x and y. Okay? And now, according to the test, it should be 2. Okay, are we okay so far? Okay, that's basically the first line. Okay? And then we say that in the case of aggregation, we want to allow aliasing for sharing. Right? So now if you go back there, we simply say this guy here. Okay? You can read it for now, and then I'm copying that to the iPad. We say LC2 dot get line at 0 dot get start, and then dot set x 100. Okay. Okay, that's basically the red. Okay, so now we're saying the following. LC2 again is here. Get line at 0 is going to refer to this particular line objects, and get a start is going to find the start, and now we're referring to this particular objects. Okay, so now if we simply set it to x, so 100. Basically, for the case of aggregation, you always return the same objects, always the same. So now, if you go back there, it's basically executing the same expression again. So now it should be 100, right? Because now it'll be changed. What will be different in the case of composition? The difference will be like this. Okay. It kind of depends on exactly how you implement it, but I'll show you one way that might be implemented. Okay, let me make a note over here. That's for aggregation. Okay. So now let's talk about composition. Composition. Okay, let me just paste that. Okay, so now, like this. I still got a red part over here. I want to say LC2 that get line at 0, get start, and set x, right? If you look at the solution, for example, okay, I'll show you how the solution looks like. If you look at the solution there for composition, yeah, line collector over there, you can see every time if I try to actually get a new line, I always return a new line objects, right? So that means guaranteed. Aliasing will not be so much useful over here. Okay, so now you can think about LC2 that get line at 0. Okay, what that will give to you is a brand new line object. I'll just write. Okay, so that's going to be just another one line with start and end. Of course, that also depends on the copy constructor for the point. Let's say we also try to create a new points. And then we got x and y. And now in this case, it would just be 2 to start with. Right? So now, if you try to do this particular change over here to be 100, you're only modifying the original line without affecting this guy here. Right? Oh, sorry about that. What I meant to say was this. Let me take it back. Let me do this very carefully. Used to be 2. Okay? And then, when I try to say LC2 that get line at, is we're talking about this particular line. And then set x to be 100, so only set x to be 100 over here. But the original one remains to be 2, so they are unaffected. That's the intention. Okay. Yeah. And then, of course, the main code to look at is the new copy constructor here. Yes.
So, like, is that the way we would draw a composition diagram? Just like draw a new
yeah. So.
object? It doesn't really connect to the.
Yeah, that's true.
vector?
You can think about conceptually, when you have composition, that means every time we use a copy constructor, it's going to create some separate, independent object structure. Exactly, yeah, yeah. What can I ask you about aggregation composition? I think most likely just about tracing. I might, actually it could be a valid question here. I'm not saying it will be, but I'm saying it might be, right? For example, I might just give you, for example, this particular 3 lines over here. Okay, I might just give you these 3 lines, and then I'll show you how I implement the get line. If you see that line, get line is going to return a new line object, you would know it should not affect the original line objects, right? Yeah, that could be a possible question. Yes?
First question, what is the benefit of this? I mean, you are changing, setting the x to 100. It is not usable. I mean, for the composition.
Because this guy here is actually in the aggregation package.
Yeah, for the composition, so after setting to 100, again, it should be 2, not 100.
It should be 2, not 100, yeah.
So what did we change? I mean, what's the benefit of
What's the benefits of this? Okay, first of all, okay, let me just clear the context. Okay, again, let's go back to task composition. Okay, if you go to task composition over here to the similar code over here, after setting x to be 100, it does not affect the original object, so it remains to be 2. Right? You can see that's why this remains to be 2. Okay. So what's happening at the runtime for this is when you actually try to execute just this part before set x, you are actually returning basically some new line objects over here. So when you say set x to be 100, you simply only change this copy here. Okay? It does not modify this particular thing. You can think about this might be useful in a scenario where you want to keep your objects read-only, for example. Yeah. Now, exactly why you want to do composition versus aggregation, you can just focus on the example we gave to you in the class. I think once you get to a more advanced course, you have to make a decision whether you want to go for either one, but not both. Yeah.
Can you go to the line composition?
Yes. Which line?
No, I mean line class.
Oh, the line class, yes. Sure. So now I'm under composition. You want me to go to line class. Okay? Sure.
So, for example, get a start or set a start, why didn't you use composition for this?
The reason is, I tell you what, somehow I admit when I was developing the solution, I didn't really go for the extreme composition because I wrote the test cases first. I wrote the composition just enough to pass all the test cases. So here's the bottom line, okay? For this course, or for later, if you're given a set of tests, go with them to actually make sure they pass, right? If you're trying to define your own application, of course, these will be the point you want to make a decision. Should you, for example, here, rather than saying return start, maybe I should say return new points and then start, right? It's kind of up to your decision, okay? Yeah, I try to do just a minimum to actually pass all the test cases. Yeah.
I think it's the same for the line collector.
Same, yeah, similar.
Position
Yeah.
that we discussed
In the foreign, yeah, exactly, yeah.
and,
Over here? Yeah, again, for the constructor over here, there was also some discussion on the forum. You guys can also refer to it. So now, I'm simply just do this dot lines is assigned other dot line. Apparently, this is creating aliasing. However, why would all the composition tests pass? It's because when I try to get a line over here, I always return a new object over here. So that will be okay as far as the test given was concerned. But your colleague actually gave some additional tests, which I didn't really supply, and that will actually fail. So again, it depends on what test you were given, right? Okay.
Can you go over the hashing of the hash function?
The hash function, you mean conceptually? Or just sure?
Before you go to hashing, I have a few questions.
Yes.
Because every time we try to return new line, so what if you want in composition to update the original?
Oh, I see. The good question. You're saying, okay, apparently for the get line edge, for the composition, you always return a new line object. Your question was, what if we really want to modify the original line objects? The response is that you shouldn't use composition in the first place. Right? You know what? It's a self-explanatory question, right? Yeah, that's true. Actually, you might start with your project with composition, and you realize that certain scenario that should not be forbidden, but it was forbidden. In that case, you should really go back to more aggregation, right? Yeah. All right. So, did it make sense? Yeah. Okay. All right. You asked about hashing. Okay. It's just about any particular example or just about idea for hashing? Idea. Okay. The best way for me to do this is like this. Okay. Okay. Again, bear with me. I want to find out what I had previously. I think we talk about hashing after JUnit test for sure. Ah, there we go. Yeah, I got it. I got it. So I can save some writing. Okay, so what I will do is I'll come back here and then paste the page. Okay, hashing. So the idea about hashing is, oh, sorry, I forgot to change back. Okay. Okay, that's something that we went over previously. Okay, how about we just go over, you may just conceptually, right? What's hashing? Okay, good. Hashing, basically, you can think about hash table is to implement a map. A map simply got keys and values. Given a key, if that exists, you can uniquely identify some value in the table. That's what we said. Hash table is a very efficient way to implement your map. Okay, let's see how that works. To make it simple for illustration, we are simply saying we got some k. Okay. Oh, actually, let's make it general. K over here can be any objects, any type of objects. Of course, integer is one of them. Okay. The idea about hashing is you want to define some function, HC, hash code. You're going to somehow turn your object key into an integer. Okay, that's called a hashing process. So you talk about hashing specifically, it is a process to convert your key, which may or may not be integer. It can be any objects. Turn the key objects into some hash code. And hash code is simply going to be some integer, some index. You're going to use the hash code as the index for the so-called bucket array. Okay? Because you might have collision for your hashing process, right? Which means more than one entries over here might just have the same hash code. Let's see example, okay? Quickly. So now, for simplicity, what we will do is this. Let's say we have a hashing function as follows. Let's say assume that k is just an integer, okay? Whatever k it is, we get a modulo 11. And once you go to 2011, they will actually talk about when you want to do this particular hashing modulo method, you have to, the 11 there is not chosen arbitrarily. You have to choose according to the size of the bucket array you have. Okay. Anyway, you will see that in 2011. Okay. So now when you say k modulo 11, let's try. Okay. Okay, that's the key. So what will be 1? What will be the hash key? 1. Good, good. Okay, and 25? 3 or 4? I heard 4, I heard 3. 3 or 4? 3, right? Okay, be careful. Okay. 3 here? Also 3. And then 14 will be 3. Okay, 6 will be 6. 39. Good, yes, I thought it's 3. Yeah, you're right, 6. That's good. And then 7? Good, very good. Okay, make sure you're okay with that, right? Yeah. So now, this is how we do it. I'll just give you an example for these two, these 3. You can see that for these particular entries over here, you can see the key for 25, 3, and 14. They have the same hash code. That's okay. That's called collision. Okay? That means distinct keys map to the same hash code. Okay, in this case, there'll be 3. So that means all these will be stored under index 3, right? Because hash code is used as an index. Okay, and then you can see under that, you're going to see 25C, you're going to see 3 and F, and also you will see 14 and Z. Okay, that's what you will see. And how do you search for a particular entry inside a particular bucket? The way to do it is by using the equals method to see whether either 25 will be matched, or 3 will be matched, or 14 will be matched, right? So also one of the examples in the slide is to say why it is inappropriate to use the hash code as the equals method. That's not good, because you cannot distinguish between distinct keys that have the same hash code, right? You may want to review that as well.
Because of like contrapositive, since if k1 dot equals k2 implies that hash code of k1 is equal to hash code of k2.
Yeah, you may think of that way as well.
But then the other way around, hash code of k1 is not equal to hash code of k2, then the keys are not equal.
Yeah, they should be unequal. Yes, contrapositive. Yes. Okay. So what Stephen was saying, you can definitely review that in the slides. Some principle over there. Okay. K1 conceptually equal to K2. That should imply the hash code should be the same. Oops. Okay, there's a principle in the slides. You have to make sure to review that. Okay. Okay, guys, any other questions? Yeah, I would say as far as hashing is concerned, as long as you understand the process of hashing conceptually, that's very important. And also the examples that we talk about in the class, right? There's several examples where I show either the equals method was not defined properly or the hash code was not defined properly. Well, look at those examples. If you can follow them, then you're fine. Yes?
With hashing, if collision isn't occurring,
Okay.
so each bucket or each key
Is mapped to a unique hash code.
so then in that case, would having a hash code kind of be like unnecessary? Because each hash
Oh, it wouldn't be unnecessary. That's a good question. Okay. Think about why we actually get to the part about hash code. Okay. If you try to recall, again, the big picture is we are trying to implement a map where we got keys and values. And we started with some naive solution, right? Which means we're simply going to get the keys, and also we got the values. Each one of them is simply just an array over here. Right? That's what we said previously, right? So now this could be For example, 1 million minus 1. So, which means we got 1 million elements in the array. So now we talk about if you want to search, given a particular key, I want to search for k. What would be the maximum number of iterations I have to run in order to find out if k either exists or doesn't exist? You may have to go all the way until over here. And just as a preview for next week, make sure you show up, okay? It's something called big O of n, but we'll get there, don't worry. Okay? It's a linear algorithm, okay? You will also learn a lot about this in 2011, okay? But we only give you a little gentle introduction in this course. So now that's naive solution. When we talk about hash code, we greatly improve this if collision is very minor, okay? You can think about given a key, okay, like a k over here. Previously, the k could not be used as an index. You got to search just one by one to see which one is equal to. But now k somehow can be converted into the hash code of k. And the idea is this particular part is very cheap. It's only to take the modulo, okay? So we said this is so-called constant operation. Actually, for those of you who actually have taken 1019, you might know what I'm talking about, O1 versus ON, okay? So now, calculating from key into hash code is a constant operation. And then what else to do? We have to use this as index for the bucket array. And then somehow, you want to see in the bucket array, I want to go to index HC of k directly. And that one is also very efficient. That one there is, again, going to be big O of 1. Okay, big O of 1. So you talk about two constant operations put together. So overall, it's also constant to get to the item, assuming that collision is not so common. So we talk about constant versus linear. So what does that mean? When n is very big, it makes a huge difference. If n is a trillion, it takes only a single operation or single cost to using a hash table. But I take a trillion to get to the final outcome, right? Theoretically. That's kind of the issue you have to worry about for 2011 and 3101. Especially once you get to 3101, you have to worry about, usually, I tell you what, usually in the exam or in the test, they will tell you a very challenging problem, and then they would say, design an algorithm of this particular complexity or better. Okay? But they would say you also receive partial marks if you can get something that works but with worse performance. That's kind of the things you got to worry about in 3101. But you'll worry about it when you get there. Yes?
If we have, like, are we going to have to explain, so if collision occurs,
yeah,
you're still going to have to search through with a for loop, right?
Oh, yes, yes. So you wouldn't be asked to write a code for this. The question Stefan was asking was like this. For example, let's say for this particular example, if I say I want to search, let's say 3 over here. Okay? The process is going to be, first of all, hash code of 3 is going to be 3. So that means go to index 3. And then this is a bucket that's not a single size, right? In that case, you have to go through the entries one by one by trying to see if the first key, make it bigger. If the first key, 25, is not equal to 3 over here, so this is not the one to look for, right? And the second one, 3, is the one, okay? So you're going to return that. Yeah, that process you only have to know informally. I wouldn't ask you to write code for this, don't worry. Okay. Well, if you can really understand the process of hashing and also why intuitively it is more efficient than the naive solution, I think that's good. Okay.
We also asked a question about like overridden and non-overridden hash code functions.
I would say, yeah, the question was if you might be asked about either you override the hash code or not to override the hash code.
Well, the result of overridden and not, like what's the difference?
Yeah, so I think as long as you can understand the example we did in the class, you'll be fine. Yeah. Mm-hmm. Okay, anything else? So far in the course, which concept have you found the most challenging so far? Recursion? Yeah, understood. How about exceptions? Exception is fine, right? Yeah. But you know what? To take my advice, even though we don't really ask you very difficult recursion question in this course, recursion is going to be your friend, basically for the rest of your degree. Yeah, many courses need recursion. You definitely need recursion for 2011, for 3101, 3311 for sure. Yes. Yeah. And again, this is not related to your lab test. Okay. Again, I'm going to say my advice again for those of you who are really curious about sharpening your skill for recursion. Google for this particular language called Haskell. It's a functional programming language. It has certain tutorials on the web that's easy to follow. So using a functional programming language to learn recursion is the best way. Okay? If you're interested, that's maybe how you can kill your time over the Christmas. Maybe. I don't know if you want to do that. Okay. Anyway, not relevant to your lab test. Okay, what I want to mention. Any more questions? Oh, good question. You mean the lab number 8? Most likely by the end of Monday. Most likely. Mm-hmm.
So that's the last one? Lab 8?
Would you hope that's the last one? It's the last one. Yes, it is. Yeah, it will be the last one for sure. Yes.
If we're on the topic of is there any way to find out our lab marks?
Oh, you know what? To be honest, I'm not responsible for marking your labs. The best I can do is to ask Professor Ma if he can hurry up. Okay. Typically, he doesn't do it until we assign you the final marks. I'll try to see if you know what? I tell you this. It should be no surprise, right? In your third year course or later, sometimes when you pass all the given tests, you might still receive imperfect marks because we might run some additional tests for you. I believe for 2030 in this course, we gave you all the tests already. So if you really got a green bar, it should be no surprise you will get just 4 marks. Okay. Mm-hmm. All right. But it's only 1%, right? Yeah.
The last lab is of 2%, right? What's special about it?
Oh, you mean last lab? I haven't really done that yet, but I'm still thinking. But you'll see that on Monday. Yeah.
Are you doing the last lab?
Have you noticed I've been doing the past few labs?
Yeah, I know.
Yeah, I'm doing the last lab.
Yeah, the difficulty is
But actually, guys, do you actually enjoy lab number 7 about expression?
that's 6.
Lab 6. Yes, lab 6. That one has a little bit to do with what you will do in 3311. Give you a little bit feel. Having polymorphic array and do some type check. I'll give you just, let me just for your information. You know what they're doing right now for 3311? I'll give you an idea. What they have to do is like this. They allow the user to build an arbitrary object-oriented model. Okay, for example, I'll give you one example here. Somehow you can have class A, okay, B over here, attributes, C over here, and then we have void, some mutator, okay, and then I will simply say, let me just add B as well. Class B, AA, CC, C, and then I will say AA, BB, okay? And then, so we got A, B, and C. Now, for this particular method over here, let's say I do B is assigned to C dot A dot B dot A dot B. Well, arbitrary. Basically, you can think about this is how the Eclipse compiler should be implemented to help you, right? To see if things will compile. Just tell me, do you think this will compile or not? It's type correct. I'm giving you some easy one. I'm just thinking on the fly, right? On my feet. Will it compile? Actually, even, I'm not sure. Actually, we'll do it together. Okay, let's try. First of all, it starts with C, right? C is of type C. Okay. So now that means we're now talking about C. Does C have A?
Yeah.
So far it's okay. And C dot A, and A is of type A. So now we're back here. Does A have B? Okay. So now we also fine. So now we talk about B. So now we're back here. And then does that have A? It does. So now hey. So we are back here. And now do we have B? We do.
Oh, we do.
We do, right? Okay, B, we have B. And now what's the type of B? B. Eventually the call chain over here is of type B. What's the type of B? B. Okay, type correct. On the other hand, if I wrote the expression like this, the right-hand side is okay, but it's of type A. A does not match B, not type correct. That's part of what they have to do for 3311. Actually, you know what? Don't be too thinking low of yourself. You can actually do it already. You just need a loop. Just for your curiosity, think about how you might do it. Yeah.
Well, since we're talking about like type correctness stuff, what exactly does instance of do?
Oh, instance of, no problem. Actually, that's important. That's important for your lab test. Okay, so guys, don't worry about this example here. Right? I'm just trying to tell you what they're doing now, so 3311. Okay, okay, instance of, yes. When you have some object expression over here, some objects, okay? When you say instance of, okay, it's a keyword. And then you give a class C, okay? That's a general format. It's going to give you either true or false, okay? It will be returning true if you can think about it in two different ways, okay? Intuitively, the dynamic type of obj, okay? This obj here, right? Obj can fulfill the expectation on C. I'll give you an example, okay? And that's one way to think about it. Number two, if you want to be more mechanical, you can see if the dynamic type of obj is a descendant or ancestor. Descendant, right? If you are descendants, that means you can fulfill the expectation. It's a descendant of C. Okay, let's do one example quickly, okay? Let's say over here. Remember we have our smartphone example. Smartphone. Okay? Now we make it simplified. Let's say we got iOS. Okay, iPhone 11 Pro. Okay, that's a very simplified hierarchy over here. So now let's say the following. If I say here, smartphone, P is assigned to new iOS. Okay, so now let's ask the following question. P instance of. I'll put down everything and then we can discuss. Smartphone over here. Also P instance of iOS, and also P instance of iPhone 11 Pro. Okay. Basically, you can see that left-hand side here is all P. Okay. So now you're basically asking whether the dynamic type of P, which is, let me mark it, is basically iOS. Whether iOS is can fulfill smartphone, can it? Yes, right? iOS is a descendant, right? True. Oops. So this guy here would be true. Okay, for the first one. What about second one? Can iOS fulfill iOS? True. Can iOS fulfill iPhone 11 Pro? No. Okay. Make sense to you? Good. Okay. You know what? I can also refer you to one of the slides you may also want to go over, since you mentioned that. Okay. Okay. If you go to the inheritance lecture, let me go a little bit further. Okay. Let me see. Okay. Yeah, this guy here. Okay, we talk about return values. Okay, if you go, this is the example we went over in the class. Okay, like last Friday. Okay, I want you to look at line number 9 and line number 10. So again, we talk about instance of. So that one there is also the good practice for you to check out. Okay, basically, how do you answer the instance of questions? You have to trace the object structure to see what the dynamic type is for that particular variable. Correct. Correct. So instance of basically is a runtime check, which means you'll check the dynamic type at that point of runtime. Yes, that's correct. Yes. Good. Oh yeah, you can think about instance of. It's just like it's like a Boolean operator. First of all, it returns either true or false. It is an operator designed just for safe casting. Okay, so now remember what we said before. Okay, again, let's see the instance of in a slightly different angle. Okay, we know that in general, if I say I do a cast, I want to cast into C, OBJ. Okay, if I want to do this particular cast, right? I know that it will compile if the static type of OBJ is, oh, right, sorry, good. Yeah, guys, don't be shy, right? We're almost the end, right? Don't be shy. Okay, so let me write a little better. So we'll talk about this general cast, right? I'm casting OBJ into C, okay? Compiles if it's either upward casting or downward casting. Okay, that's number one. Okay, and then you got ClassCastException. Okay, again, don't write CCE in the written test, right? ClassCastException. Okay, ClassCastException if the dynamic type of OBJ is not a descendant class. Of C. Because if that's not a descendant, it cannot fulfill what's expected on C. Okay, that's what we know. The instance of will be a very useful operator for you to do some extra insurance, basically, right? So that's to say, before I can try to do, because I got a risk to run into this particular runtime exception, right? If I didn't cast properly, what I can do instead is to say if over here I can say OBJ instance of C. If it is the case, I do the cast. Otherwise, I don't do the cast. Okay, that's why instance of is there. That's its main purpose. But I know that for your lab number 6, okay, you guys were trying to also, you were expected to say, well, if I got, for example, at or, right? Okay. If you don't mind, I'll just mention quickly, right? I don't mind telling you. Let's say if this is the array for at or, for example, right? It's polymorphic because every one of them can be an expression, right? So that means over here it could be maybe addition dynamically, right? Statically is simply expression and then array, right? That's what we said in the class. So now it can be addition, it can be multiplication, and it can be greater than, and etc., right? So now, how do you determine if this particular at or is type correct? You want to make sure you can actually add up everything together, okay? Conceptually, you definitely cannot say 2 plus 3 plus 3 multiplied by 4. So far it's okay, but to say plus 3 larger than 4, it doesn't make sense. So that means as soon as you find out something that dynamically is not an instance of, let's say, integer expression, then you can you can say no, it's not type correct. Okay.
What is the syntax for to say this instance of integer? What is the syntax?
Oh, I see. So you want to say a class name, right? So you might say, for example, let's say 0, 1, and 2, right? You may want a loop to say loop counter is I. Okay. You may want to say, let's say this expressions, EXPS. Okay. Expressions over here at position, for example, 1. Okay. Instance of. Okay, you want to say it's instance of, for example, addition. That's one possibility, right? Or, right, remember disjunction, right? You can say expression is 1, instance of multiplication, and etc. Okay, since it's a Boolean operator, so you can actually combine it using disjunction or conjunction. Depends on what you need.
Like it would, for example, get value and then compare them.
Oh, that's also fine. Yeah, I noticed that some of you actually try to use the value as opposed to the expression type. That's also fine. Yeah. For that, I wouldn't go into so many details. Yeah. Okay. But I think it's a nice pattern, for you to actually check. Okay. Any other questions? We still got time. Right? But if you have no question, that's fine too. Do you guys think you'll be okay? Do you need any more time before Tuesday? You should be surviving, right? Okay. Do you want another session? Yes? I will try to confirm with you, okay? If there's going to be another session, it may be just Monday. Okay, yeah. Tentatively, it could be about maybe 10 a.m. or something. Okay, but I'll confirm with you. Okay. Yeah. If I didn't get in touch, that means sorry, no. I'll try to. Okay. Yeah. Yes, question.
Is it practice to do the lab 7 or just a study for?
Oh, you mean for the written test? Oh, when is lab 7 due? Next Wednesday? Oh.
So
Oh. You know what? It's tricky because apparently interface and abstract class, they are not covered in the written test, right? I would suggest the following, okay? Maybe, assuming that you're going to work from today, right? Assuming that you have no weekend, right? What you have to do is maybe until Saturday night, you can do lab 3, do as much as you can. But I think lab 7, sorry, I keep confusing myself. Yeah, because for 3311, they only got up to lab 5. But for you guys, you got lab 2, anyway, lab 7. Okay, for lab number 7, I would suggest, I'm going to upload a lecture for today about interface. It's kind of the second half of the lecture. If you didn't make it to the morning, please watch that. I think that one is going to help you on completing your lab number 7. Okay, complete as much as you can by Saturday night, and then you want to draw a closure on that for there, and then continue to prepare for your written test. Okay, so you still got Sunday and Monday, and maybe for Monday I'll try to see if I can schedule just another one for you. Okay, so you can still ask me questions. Okay, yeah, all right. Any other question for today? Feel free, it's your time. Okay, if no, then okay, good. Have a good weekend, and I'll confirm with you about Monday. Okay.